Hello, this is the Tepid Coder. This video is going to be a follow-up from my previous C++ Variadic Template video, where I was discussing how to make Sqlite more type-safe and easy to use. In this one, rather than focusing on inserting different values into the database with type deduction, instead I'm making it so that selecting values from a table and binding output arguments is done with type deduction. Now, this may not be the most clever or easy way to do it, but it's a way to do it that's still, I think, a bit easier than the typical way of having to call the proper function. This does still require some runtime checks to see what kind of type is being returned from the database, because the database itself can't really be compiled into the code unless you make specific class objects that relate to the tables and you keep that up to date with the database itself. But then you're making some assumptions which might be bad, so... Although I guess this is also making some assumptions which could be bad in that case. Essentially, I'm assigning some variables into a vector of some class that I made, and this class references some types. And depending on the types you pass it, it's going to hold a reference to whatever you specify. So it could hold a reference to a string, or an integer, or a double, or it could also hold a reference of standard vector uint8t. That would be your blob type, right? So, blob, let's call it. Anyway, I didn't show the blob in this example, but it should work. So, the way I did this is I have a vector of these types that can hold references to these places in memory. And then the constructor of these Sqlite type classes that I made actually looks for a string being passed, or an integer, or a double. And depending on that type, it actually uses a union inside of the class to hold the reference to that type. And it also has another flag that says, with an enum, what type it's holding. And in place back lets you pass the constructor arguments directly to the constructor. So this just gets forwarded to the constructor of this class type right here, makes an object and puts it under the back of this vector types. So because I'm passing a string here, it knows to call the string constructor. Because I'm passing this here, right here, the integer, it knows to call the int64 constructor. Same with a double constructor, and in this case it would be the vector of unsigned 8-bit integer constructor. Anyway, so what I do here for my selections, I say pass the database context, pass the query you want to do, and then pass your output arguments, and finally pass the variables that you want to replace, like the question marks, right? This could be any number of variadic arguments, but in this case I'm only passing this. So I guess I'll show the class now. So if I go to Sqlite type, here it is. I have a union here. I can either hold a string pointer and what do I say, assigned 64-bit integer pointer, or a double pointer, or a vector pointer to a vector that contains unsigned 8-bit integers. So it can be any of these. And then I store the type that was actually assigned to the constructor. The default constructor is deleted because I don't want an unknown type. So it has to have a valid constructor. Then I have a bunch of assignment operator overloads I can use for assigning a new string value to whatever string I'm holding a reference to in here, or a new integer value to whatever integer I'm holding a reference to right here, or double, or blob. You get the idea. And I can also return the type that was stored in the constructor right here. Now this is pretty interesting because I haven't shown how to initialize a union with an initializer list yet. What I'm doing is I'm using like a C-style initializer list and saying like dot the name of like a structure, for example, but in this case it's a union, equals something. So you can actually do that inside of your C++ initializer list. So that's kind of a cool thing I was able to show off in this video. Anyway, yeah, so I assigned the type that was assigned here. I was passing an integer, so look, it's type integer from the enum. And here's a reference to it, I'm storing that. It's passed implicitly by reference, but I'm also having to reference that because it's treating it just like a standard int64, but I'm able to modify it. So if I reference it again, I'm actually getting that as a pointer. Okay, I do the same thing for the double, I do the same thing for the vector, I do the same thing for the string. That's basically it. The assignment operator overloads, a little bit more annoying, but essentially if I have a pointer to a standard string, so I have standard string pointer like this, then I can say, if I dereference that, like this, then that equals a standard string. And standard string has standard string operator equals. It's got an overload like that. Anyway, that's what I'm calling here. I'm basically dereferencing it to get the underlying standard string, and then I'm calling that operator overload and assigning it to a string. So that should automatically convert this const char string into a standard string. Now if you notice in the constructor, it's actually taking an unsigned character pointer. That's just because Sqlite, when you call the Sqlite 3 column text, returns an unsigned character pointer. I think it's because it wants to be, I don't know, explicit about the fact that it's accepting UTF-8 text, right? So either way, I'm just casting it back to a const char because I'm only using regular ASCII text anyway. For a vector, it's a little bit more difficult. You have to have a const void pointer, so it can't be modified, and it's a pointer to some arbitrary type. And then you have to call a second function with Sqlite, which is Sqlite 3 column bytes, which tells you how many bytes long the returned data for that column position is. So if you're returning, like, say something like I'm returning a str name, I'm returning, I don't know, ICT4 age and double, it's going to be like double height, right? So for column 1, it's going to return the size in bytes of that, right? If I call Sqlite 3 column bytes. I've only ever used it for a blob, but you could probably use it for other types too. But this would be position 1, position 2, position 3. You select it, so select these things from users, right? Anyway, so instead of using an operator overload and assigning, I can't really do that unless I store it in like a temporary vector or something and just copy from the vector. So instead I'm saying there's a dot assign blob function for this Sqlite type, and you can pass it the arbitrary data and the size in bytes of that data. And it's just going to create a new vector out of that and copy that into the currently stored vector, the one that's being stored by reference. And again, you can see I'm dereferencing it because I have a vector pointer, and by dereferencing it, I'm getting the actual underlying vector, and it has a assignment operator overload that I can use as well. Okay, and then for assigning a integer or a double, I'm passing by const reference because you can also use this just for a temporary value, as I showed in an earlier video. This just lets me get the type so I can decide which of the Sqlite functions to call. So let's actually take a look at that. If I go down here, it's inside my select function. It kind of does the same stuff as the previous query function I made, but I've renamed them to be insert and update. Update just updates the database and returns true if it succeeds, returns false if it fails. Insert actually returns a new row ID. So if you insert a new record, it'll tell you what the ID of that record is. Okay, but select is different in that you pass a database handle, you pass a query, and then you pass some output arguments to store the results in, and then you do your Variadic template stuff. So anyway, it'll still do the preparation for the statement. It'll still do all of the Variadic, template argument stuff to make bindings, and then it will actually step through. And if it succeeds, great, we can get some results. If not, we return false. But if we can get the results, then we look at all of the output arguments you have bound inside that vector we passed, right here, the Sqlite types, which remember can hold references to integers, doubles, standard strings, or standard vectors of unsigned 8-bit integers for blobs. So we're covering all the basic types except null. And that should be fine in most cases. So right here we have the type function I mentioned that tells the type in the enum. If it matches this enum type, integer, then we're going to call Sqlite 3 column index in 64, and we're going to use that operator overload for an integer. We can also use the operator overload for a double, and we can do it for text, which is going to be an unsigned character pointer. And finally, we have the same one for a blob, which is going to use that vector of unsigned 8-bit integers, but it's using a signed blob here. In the default case, something went wrong, because we can't even default construct to get this unknown type. But if somehow that happens, a memory corruption or something, bad RAM, it's going to return false, it's going to finalize the statement and bail out. And each time it wants to bind to a new output argument, it's going to increment the column index that it's pulling that value from. And when we're done, we finalize, it return true. So I want to actually show this thing running. Let's compile it. Boom. Now you can see right here, what we have is the initial locations of memory of these variables, the string, the 64-bit signed integer, and the double value. And you can see when I call the constructors, it also shows the position in memory of those values that it's referencing. you can see right here it's pulling out the tepid coder. Age 77, height is 7/100ths of some unit. Okay, let's go back to the main function real quick. So main, if I'm sure I'm printing that out. I'm actually using fprintf because I'm using $p for pointers. I did that in constructors as well, being kind of lazy there. There is a way I can do that with cout, I'm sure, but I think I cast a void pointer actually would do the same thing. Anyway, I'm just more comfortable with this because I've been using it for so many years. But you can see I have these 3 variables that I'm binding as output arguments. I'm showing their addresses. And then inside of the constructors, if I go to Sqlite type, Sqlite type, you can see right here I'm printing out the position in memory of the thing that was passed to me. And you can see I'm doing that for all the constructors. And it's the same in these cases. If you want to freeze frame the video, you can compare the stir here with the string here. You can compare the signed 64-bit integer here with the signed 64-bit integer here, and the double here with the double there. And of course, it worked. So I mean, that's also some kind of evidence. And I can show it inside of the database itself too. If I do, where is it? Sqlite 3. I do .open. It's going to be code tepid coder. It's going to be Variadic Template with Sqlite. And it's going to be some database.dat, I believe. Okay. .schema. There it is. Select everything from users. There it is. You can see I have a bunch of repeated data in there, which is fine. And I could say something like select everything from users where stir name equals, and I'll say the tepid coder. Oops, didn't mean to put the backslash there. There we go. And you can see that's exactly what I'm doing in the function too when I select. So if I go back to my main function, you can see I'm selecting where stir name equals question mark. And question mark is the tepid coder here. That's my Variadic template argument. So if you found this useful, if you liked it, give it a thumbs up. Consider subscribing for more content like this. If you have any suggestions or criticisms or questions about this, please post those. I'd be interested to see if any of you have made similar solutions to the same problem. I could think of 2 or 3 other ways of doing this that don't involve filling a vector full of like references, have their own drawbacks, right? So yeah, I'm not sure what I like best. I feel like this method right here is kind of bad in the sense that you'll probably have some repeat code, but you can also abstract from this by sticking the same kind of call right here into some kind of like class that manages users or something. And then if you make any change to the user class, you would also make that same change in the database. And then whenever you try to query something like looking for a certain user, you would just call the function from that class that does this internally. So this isn't necessarily a bad thing in of itself, but it's not something you'd want to probably stick with permanently. This would be like an intermediate, like middleware type solution that you would abstract from. Anyway, I'm going to leave it at that. You guys have a great day. I will catch you later. Happy coding.